So in the next problem, we're asked to solve a problem related to a football. A football is kicked east at 36 meters per second at an angle 54 degrees above the horizontal. So it's handy that we just figured out the x and y components for a vector that looks just like that. In this case, I'm going to sketch out the trajectory to start. The nice thing about this problem is that the ball is going to be launched from the ground. It travels up for a little while, and then it goes back down to the ground, which means that its overall displacement from launch to landing is going to be 0 in the vertical direction. So from launch until landing, its only displacement will be in the horizontal direction. Initially, it's going to have some initial velocity, which we already figured out the x and y components to before, so that's going to come in handy as well. It's also useful to point out that this problem is, very nicely, symmetric. So that might come in handy too later on. It's a good thing to make note of right now. So like any problem, I'm going to lay out my x and y direction. In this case, x is actually east. That was indicated in the question, so I'll jot that down so I don't forget. And I'll choose y to be upward positive, but you can choose whatever you want. So in the first part of this problem, we're asked, what is the maximum height of the ball? So like other problems that we did before in one dimension, when an object is thrown upward and falls due to gravity, at the maximum height, that velocity, that vertical velocity component will be 0 at that moment. So for the first part of this problem, for A, I'm actually only interested in the y direction, just like when we did problems like this before. I know my initial y velocity, we just figured it out during the last question. It's 29.1246 meters per second with 3 significant figures. And since I'm interested in the maximum height at the apex of its trajectory, the final velocity at that point in the y direction will be 0. I also know that the acceleration due to gravity is 9.81 meters per second squared down, and I would like to find what is the vertical displacement at that point. So if I look at the variables, the kinematics equation that I'm going to want to go with is this one. And in this one, I have some simplifications I can make. V2 is 0. So that means when I'm solving for delta dy, I'm going to get negative v1y squared divided by 2 times the acceleration in the y direction. Substituting in some numbers, I've got my initial y velocity, 29.1246, which will be squared, divided by 2 times negative 9.81. And I'm dealing with 3 significant figures for that calculation. I'm going to end up with a positive number, which is good because obviously that maximum height is in the positive y direction. And my final number will end up being 43.2336 meters, rounded to 3 significant figures. So the maximum height of the ball is 43.2 meters.